Okay, so today is 5/13/19. This is the second page of Newton's first law of motion. Notice that these two go together. So this is A, this is B, this is C, this is D. Okay? So looking at this one, inertia is when an object resists a change in motion. This resistance often occurs in the opposite direction of motion. So I would say yes, inertia is when an object resists change in motion. This resistance often occurs in the opposite direction of motion. Yeah, I'll agree with that. So this statement is true. For example, applying brakes in a car. In the car, the driver is thrown forward. And I guess thrown is kind of an interesting word. I wouldn't necessarily say that we're thrown forward when the brakes are applied. You're just going to kind of move forward. Let's see. Let's see a tiger. He's kind of okay. He's doing a good enough job. So now looking at B, an object. If an object is already in motion, it is likely that the motion will change without any input from outside forces. And if an object is already in motion, it is unlikely that the motion can change without any input from. So without any. So it can change without any. So it's saying that if an object is already in motion, that it can still change without any outside forces. So that is going to be false. You're going to put an outside force needs to act upon an object in motion to change it. In order to change it. Okay, so to read it again, an outside force needs to act upon an object in order to change its motion, direction, speed, whatever you want to say. We'll put a panda. All right, so looking at C, friction opposes movement of objects on surfaces. Smooth surfaces often slow objects down. So friction opposes motion or movement of objects on surfaces. Smooth surfaces often slow objects down. So smooth, no. So that's going to be false. Surfaces that are rough slow down objects. Not smooth. Okay, so surfaces that are rough slow down objects, not smooth. So it doesn't mean, unless it's a perfectly smooth surface, it can still slow down a little bit, but rough surfaces are primarily the ones. So this last one, the force of gravity pulls objects towards the center of the earth. Everyone knows what goes up must come down. Duh. Hopefully you're like, okay, that one's an easy one. So true, gravity is a force of attraction, and the direction is down. Okay, really easy for those. That's all I got to put for that. Okay, so gravity is the force of attraction, and the direction of pulls is down. That should be pretty common sense at this point. So let me put another I'll add a little wolf to it. Okay, so now by sight, can you identify anomalies? Cross out any examples that are incorrect. So if he's moving this way and this way, this doesn't look like a mouse, but this is going to be true. So these are correct examples of Newton's first law. Okay, and it is true because as the hamster runs forward, the wheel turns in the same motion. The same motion. Duh. So as the hamster runs forward, the wheel turns in the same motion. Okay, that one should be relatively easy. All right, Mr. Chipmunk. There you go. This guy So as he's skating forward, there is a force that is pulling him back. Hopefully by now you've realized that yes. But as he's pushing back, so this is the opposite force, it's still moving forward. So this is true. This is a true picture because pushing back on one foot, pushing back on one foot allows the skater to move forward. Okay, pretty easy. All right, these should be relatively explanatory, but who knows? We'll put our little cheetah, leopard, whatever you want to call this thing right there. All right, this guy running up a building. This is not the comics, so this is definitely going to be a false example. Law of gravity prevents vertical walking up buildings. Duh. Okay. That's last one. We're just going to do some matching, and then ta-da, you are done. Let's use an animal we haven't used yet. Oh, Monsieur Polar Bear. Okay. So looking at these, a push or pull acted upon by force. 2 is blank. Surface resistance to relative motion. 4, a force of attraction between 2 masses. And 5, the resistance of change in motion. Well, looking at this, I'm going to go ahead and say, I know probably the easiest one is C, a force. It's a push or pull. Okay. What else do we have? Inertia, surface resistance relative to motion. Inertia, if I'm looking back up at the top, I know inertia is the resistance to change in motion. Okay, so 5 and A go together. C and 1 go together. Let's see. Gravity, friction. Well, so I know friction is surface resistance. So B and 3 go together. See, a force of attraction between 2. I know that's gravity. So E and 4 go together, which means that we have one that is missing. So the first law of motion, we're just going to put an object in motion remains in motion. All right, that's all you got to put for that one.